big jump. We're going to be going back to complex numbers. Um, and complex numbers were a plus bi. Remember, imaginary friends always in the bag. And if we graph a complex number, the horizontal axis is the real axis, and a vertical is the imaginary. So 3 plus 2i would be 3 right, 2 up. This point, the point negative 1, 3, it could be represented as negative 1 plus 3i, left 1, 3 up, and so forth. So where would 1 minus 3i end up at? Well, that'd be right 1, down 3, so that would be in quadrant 4. What about negative 1, negative 2i? That would be in quadrant 3. 2 plus 2i, right 2, up 2, that's quadrant 1. Now, the absolute value of a complex number is actually its distance from the origin. So if I have this a plus bi, its distance from the origin would be found by taking its horizontal component, a squared plus b squared equals that distance squared. Doesn't that look familiar? Isn't that kind of like magnitude? It is. So if I was wanting to graph negative 2 plus 5i, that's left 2, up 1, 2, 3, 4, 5. There's the point, negative 2 plus 5i. And its absolute value, kind of like magnitude, is going to be the square root of the horizontal component squared plus the vertical component squared. Oh, I forgot to plot it. 3 minus 5i would be right 3, down 1, 2, 3, 4, 5. There's the point 3 minus 5i. And its absolute value would be its magnitude, its distance from 0. So horizontal component squared plus vertical component squared. 9 plus 25, square root of 34. Now, we can also write complex numbers in a trigonometric form. And I want to compare this to how we could write a vector. So a vector could be written as its magnitude times the cosine of the angle plus what it was in vector form, that was the horizontal component. And then the vertical component was sine. Well, here, a plus bi, a is the horizontal component and b is the vertical component. R is written as that, magnitude, a squared plus b squared, square root of that. So really what we're talking about is that we're taking r, that's my absolute value, my magnitude, plus r. It's the same kind of thing, the horizontal component, vertical component. The way this is written is a little bit different because they kind of factored out an r from each of those terms. And they put the I in front of the sign. That's just a traditional way of writing it. And to find the angle, we're going to do b over a, rise over run, y over x, sine over cosine, however you want to see it. So here's my a, and my b. First, I need to find r. Horizontal component squared plus vertical component squared. So that's going to be a 4 plus 12. Well, this one turns out nice. R is 4. Now to find the angle, the tangent of the angle is the y value, so b over a. And it was negative over negative. So x and y were both negative. I'm going to pull out my unit circle. Both of them were negative, and I ended up with a square root of 3. So the y had the square root of 3. The other one didn't, so it's over here. It would be that angle, which is 240. Now, if I did it in the calculator, just the square root of 3, it would actually give me 60 degrees in the calculator. Calculator would say 60 degrees, but that's in quadrant 1. This is going to be in quadrant 3, so my angle is actually 240. So let's rewrite it. The r is going to be on the outside, and then I'm going to write cosine of 240 plus I sine of 240. Where is this one going to be? Negative 2i. So it's not going left or right at all. It's just going down 2. So actually, if I'm thinking about where it is on the circle, it would be down here. So it'd be on this angle 270. And r, that distance, is just going to be r. There is no a, so that's 0 squared plus negative 2 squared. R is just going to be 2. 2 steps down. And the angle is going to be 270 degrees. Or I could do 3 pi over 2, depending on whether the instructions ask me for degrees or radians. And I can write that as 2 parentheses cosine of 270 plus I sine of 270. Now, in some textbooks, you'll actually see it written as a different way because people got tired of writing all of that. They'd write 2. Let's see if we can tell where the CIS comes from. Cosine, I, sine. If you look at different textbooks, you'll see it that way as well. Now, what if I was given the trig form and we're trying to go back to standard form? Well, basically, you're going to kind of just distribute. So this is in radians. I can look at my unit circle. That's one way to do this. So I will do it by hand first. Cosine of negative pi over 3 is going to be 1/2. And sine of negative pi over 3, I'm looking at my unit circle, would be negative square root of 3 over 2. And so when I distribute, I get the square root of 8 over 2 plus a negative square root of 24 over 2i. I could actually simplify that. 8 has 4 in it. 4 times 2, so 2 root 2 over 2. And this also is a multiple of 4. That'd be 2 square root of 6 over 2. Square root of 2 minus square root of 6i. You could also do it in the calculator if you wanted to. Now, working with these trigonometric forms, there's some formulas. So the product of two complex numbers in trigonometric form, we're going to multiply those magnitudes or those absolute values together, and then add the angles together. So I'm going to multiply the r's together, and then I'm going to add the angles together. One-fourth, three-fourths is 1 whole pi. Here's another one that's means multiplication. So I'm going to multiply the r's together. And then I'm going to add my angles together. So 1 pi over 2 plus 3 pi over 2 is 4 pi over 2. That's going to be 2 pi. Says do the proper operation, then convert it back to a plus bi. Ooh, okay. So 3 times 4 is 12. I don't know why this one has smaller room. Because if I have 1 pi over 3 and pi over 6, I'm going to come off to the side. Pi over 3 plus pi over 6. That's going to be like having 2/6 plus 1/6. That's 3/6. That's pi over 2. Okay, so cosine pi over 2 plus I sine of pi over 2. And I've got my unit circle right in front of me. Cosine of pi over 2 is 0. And sine of pi over 2 is 1. So I end up with 0 plus 12i. The quotient. I'm going to divide the r's, and guess what? I'm going to subtract the angles. So this one doesn't have a number in front of it. That means it's a 1. This one doesn't have a number in front of it, so that means it's a 1. Now I need to subtract those angles. So 7 pi over 4 minus pi. Well, that's 7 pi over 4 minus 4 pi over 4. That's 3 pi over 4. This means to divide. 18 divided by 4 is going to be 9 over 2. Cosine of, subtract the angles.